Continuing with section 4.3, let's look at example 3. The reason I picked this example is because here the initial conditions are different than you have seen normally. Often you have seen that initial conditions are given at the value 0, but they can be given at any other value as well. Now, the process of doing this problem is exactly what we have doing before. Start with the auxiliary equation, find the roots of the auxiliary equation. Depending on the form of the roots, you write the general solution. So in this case, we are getting the roots of the auxiliary equation are 1 plus minus I, which gives us A is equal to 1 and B is equal to 1. So we can write our solution here. General solution. Now we find the derivative of the solution, and now to find the derivative you have to be careful because there are two functions being multiplied in each term. There are two terms in the derivative. One is this one because we take the linear combination of the two functions, two solutions to make a general solution. So this is one term and this is the second term. So when you take the derivative of the first term, C1 can be considered as a constant, or you can attach C1 to one of these functions. So I am going to keep it outside because it's a constant, so you don't differentiate the constant, you differentiate the function. So C1 times the derivative of e to the t cosine t. When I do the derivative of e to the t times cosine t, I use the product rule, which I have mentioned over here. So it will be keep the first function as it is, multiply by the derivative of the second. So e to the t times derivative of cosine t, which is negative sine t, plus now keep the second as it is, which is what I have here, and take the derivative of the first. But the derivative of e to the t is just e to the t, so I got that as my answer. And in the same way now we can do the derivative of the second term, again keeping the c2 outside and applying the product rule on e to the t sine t. We end up getting this derivative. Now we have to apply the initial conditions. So remember, y of pi is equal to e to the pi, means wherever I have y, I will be replacing it by e to the pi, not 0, e to the pi. And then wherever I have t, I will replace it by pi. So I did that here in this. Take the function, this is the function equation. So plug in e to the pi for y and plug in pi for t. So we end up getting this. Now sine of pi is 0 and cosine of pi is negative 1. So we end up getting equation e to the pi is equal to negative e to the pi times c1. So that c1 is equal to negative 1. In the same way now we use the other condition, which means that when t is pi, y prime is 0. So I will plug in 0 for t and 0 for y prime and pi for t wherever I see t, and so I'll plug in and just evaluate, and in the end we see c2 is equal to 1. So that gives us the solution. So c1 is negative 1, so negative e to the t cosine t, and the c2 is plus 1, so plus e to the t sine t, or you can write it like this. Okay, next example. So again, auxiliary equation, we start with the auxiliary equation. We end up with these roots, which give us that a is negative 1, b is square root of 3. Write your general solution here. Different derivative now of that. So again, like the previous example, you have a product of functions, so you have to use the product rule. Again, let me write it here. So see, every time you use the rule, if you write it on a side, then you will remember it. So I did that, and then I used the initial conditions and So this is what the answer is. So you should be able to follow this, and if not, then you can ask questions. So there is one last example left, which I'll do in the next video.